Let's solve the absolute value inequality in two different ways. First, we'll use the boundary point method, then we'll use equivalent absolute value equations. Let's solve this absolute value inequality using the boundary point method. The boundary point method is a four-step process. The first step, we take this inequality and we make it an absolute value equation. So we solve the absolute value of 2x minus 1 is equal to 7. We solve that by solving 2x minus 1 equals 7, or 2x minus 1 equals negative 7. For the first equation, we have 2x equals 8, x equals 4. Or, for the second equation, we have 2x equals negative 6, x equals negative 3. We've done step 1. We found the two boundary points for this absolute value inequality. In step 2, we're going to take these boundary points, x equals 4 and x equals negative 3, and place them on a number line. Negative 3, 4. Now notice, on the number line, we really have three different intervals. We have the interval to the left of negative 3, the interval between negative 3 and 4, and the interval to the right of 4. Now we're ready for step 3. In step 3, we'll choose a test value within each interval. Let's start off to the left of negative 3. Let's let x equal negative 4. We can choose any value in this interval. I'm just choosing a value that's close to negative 3. When we choose negative 4, we substitute it back into our original absolute value inequality to see whether it produces a true or a false statement. So let's substitute negative 4 in. We have the absolute value of 2 times negative 4 minus 1 is less than 7. This is what we're asking. Well, inside the absolute value, we have negative 8 minus 1, or negative 9. So is the absolute value of negative 9 less than 7? Is 9 less than 7? No, that's a false statement. So that interval provides a false solution. Between negative 3 and 4, let's choose an easy value. Let's let x equal 0. When we substitute that in the original absolute value inequality, we're asking, is 2 times 0 minus 1, the absolute value of that, less than 7? In this case, we have the absolute value of negative 1. Is that less than 7? That's true. 1 is less than 7, so the interval from negative 3 to 4 provides a true statement. And to the right of 4, let's let x equal 5. Let's substitute 5 in our original inequality. Is the absolute value of 2 times 5 minus 1 less than 7? So we have the absolute value of 9 less than 7. Again, we're asking if that's true or false. It's false. So now we're ready to move on to step 4. In step 4, we write our solution set. The only part that provided a true answer was the interval between negative 3 and positive 4. So we write our answer as the set of all x such that negative 3 is less than x is less than 4. We keep it as strict boundaries because it's a strict inequality here. The solution set on our graph will be the open interval between negative 3 and 4, and the interval notation will be the open interval from negative 3 to 4. Let's solve by using equivalent absolute value equations. If we have an absolute value inequality with a less than symbol, we can rewrite this as a compound inequality by removing the absolute value symbols and rewriting the original inequality. Since it's a less than, and it's less than 7 in this case, we also write on the other side greater than negative 7. So in other words, we solve negative 7 is less than 2x minus 1 is less than 7, and this compound inequality means exactly the same as our original absolute value inequality. Let's add 1 to all three parts. We have negative 6 is less than 2x is less than 8. Let's divide all three parts by 2, and we have negative 3 is less than x is less than 4. Our solution is the set of all x such that negative 3 is less than x is less than 4. Our graph is all values of x in the open interval between negative 3 and 4. And finally, our interval notation, we can just look directly at the graph and write our parentheses, negative 3 to 4, closed parentheses, so that we have an interval from negative 3 to 4, but not including those endpoints.